So chapter 7 is a bit of an outlier in a sense that there's not really any new mathematics involved here. It's all ideas that we've seen before, it's just a more difficult level of application. So let's start with example 1. Example 1, we've seen questions like this before. It shows you that a particle is in equilibrium under the forces shown, and says by resolving horizontally and vertically find the magnitudes of forces P and Q. So when we look at this diagram, if it's in equilibrium, right, so equilibrium means that the forces are balanced. Okay, so it's not moving anywhere, there's no acceleration, the forces are going to be balanced, right, because it's in equilibrium. That key point that it's in equilibrium is going to give you that. So then when we do this question, we resolve horizontally and we resolve vertically. So let's do vertically first, not that it really matters. So we look for the positive direction being up, so we know that all the upward forces are going to balance with all the downward forces. So when we look upwards, we see that these two are both pushing it up, but they're also pushing it across, so they're at an angle. And again, we can use our rules we've been using all the way through the unit to move to the vertical component. Both of those are moving away from the angle, away from the 45 and away from the 30. So that first one is going to be 4 lots of sine 45, always sine when we move away. And the other one is P lots of sine 30. So they've got to balance with the only force going down, which is Q, and Q is straight down, so we don't need any sine or cos and an angle. We can then go to the side, right, so to the right hand side. So if we take right as positive, and we've got that this one is P cos 30, that's the only one going to the right, and the only one going to the left is here, which is 4 cos 45. Right, and obviously the Q doesn't come into it because the Q is only a vertical force. So then we look at those, there are two equations. Hopefully we spot that the second one only has one unknown P, so we know that from the second one that P is 4 cos 45 divided by cos 30, which is going to give us an answer. Gives us 3.27 newtons to 3 significant figures, and all I'm going to do is substitute that into the first one and we'll get Q. So then Q equals 4 sine 45 plus 3.27 ... because I'm going to use my full calculator accuracy, times 30. This gives us 4.64 newtons to 3 significant figures, and there's your two answers, P and Q.